friends, welcome to my YouTube channel Forcetra. Myself Mudita Bansal. In this video, we are going to solve previous year IBDP paper 1 questions. We will solve 5 questions and the next 5 questions would be in next video. Forcetra, precision learning and powerful results. So contact us for one-to-one tutorials or any doubt solving classes. You can mail me on forcetra.physicss@gmail.com or WhatsApp me on this number. Or to book any session with me, you can scan this and DM me on the WhatsApp. Let's start with the new question. Wire X and wire Y are connected in series in a circuit. Wire X has 3 times the radius and 1/3 of the charge carrier density of wire Y. So Rx is 3 times then the radius of Y and the charge density of X is 1/3 of charge density of Y. So it is connected in series. Connected in series. So the current from X would be equal to current from Y and the current is equal to NEAVD. So N of X, area of X and drift velocity of X is equal to N is the charge carrier density of Y. E is the charge of electron. E area of Y into drift velocity in wire. So E would get cancelled and let's use this two equation and let's substitute in this. So area we know area is equal to pi r square. So let's substitute in this. So it would be 1 upon 3 ny and this area would be pi r radius of x square. So this pi would get cancelled from both the sides. So it would be pi ry square. So instead of Rx, I am substituting the Rx value which is 3Ry square of it and the drift velocity of X. And this would be equal to charge density of Y into radius square of Y into drift velocity of Y. So we have to find the drift velocity in X and this upon drift velocity in Y. So V dx upon V dy we have to find. So it would be ny ry square upon it would be 3 times ny it would 9 ry square. So when you solve it, it would get cancelled and you get 3. It would be 1 upon 3. B is the correct option. A cell of negligible internal resistance is connected to 3 identical resistors. So this is R, R and R. The current in this cell is 3 ampere. The resistors are now arranged in series. What is the new current in the cell? So let's say the battery is having EMF of E and let's find out the total resistance. So the equivalent resistance of these two parallel resistance would be R by 2 because they are equal and connected in parallel and this resistor is attached in series with these two parallel resistors, so it would be R plus R by 2. So R equivalent in this case would be equal to 3R by 2. Using the Ohm's law, we can write E is equal to equivalent resistor into current. So when the resistors are now arranged in series, so all the three resistors arranged in series in the second case, R equivalent in second case would be equal to 3 times of R. All would be added 1 plus R plus R plus R. So it would be 3R. So E would be same. The sign has not been changed, which is equal to 3R into current. Let's equate the EMF from both the sides. So it would be 3R into I is equal to 3R into 3 upon 2. So 3R would get cancelled. I is equal to 3 by 2 which is 1.5 ampere. B is the correct option. What is correct about the energy change and the terminal potential difference during the discharge of the practical electrical cell? So in electrical cell, chemical energy is converted to electrical energy. So A or maybe B is correct. Let's see about the terminal potential difference. Terminal potential difference decrease uniformly over the cell lifetime. Okay. and second is decrease significantly at the end of the cell lifetime. So potential difference of a battery does not decrease uniformly. It decreases depending on the lifetime of the cell. So B is the correct one. At the end, it decreases significantly. A loop of the wire lies in the magnetic field directed into the plane of the page. The loop carries a current in clockwise direction. Okay, so this is the current flowing in the wire, and the magnetic force acting on the wire tends to rotate the loop around the x-axis, rotate the loop around the y-axis, reduce the radius of the loop or increase the radius of the loop. So to solve this question, we has to take help of the Fleming's right hand rule, which says that these fingers represent the magnetic field, the thumb direction representing the current direction, and the perpendicular this perpendicular to the palm is representing the force direction. So let's find out the force at this point. When the current direction is this is towards the right and the magnetic field is inside the paper, so the force direction is towards the y direction. So this is the force direction, and at this point this is the I, so this would be the force direction. At this point this is I, a small element we can take, and this is the force direction. So what is happening at this point? This is I direction and this is the magnetic field. This is I direction now, and so force would be downward. So it would be in negative y direction. So this is force direction. So at each point we are seeing that for what this force is doing, force is actually trying to increase the radius of the loop. D is the correct option. A car on the road follows a horizontal circular path at constant speed. Circular path it is. What is the direction of the net force acting on the car and the direction of instantaneous velocity of the car? So whenever there is a horizontal circular motion with constant speed, then the force acting on the body is towards the center, which we call as centripetal force. So force is always acting towards the center of the circle, towards the center of this circle. So the or this, and the velocity at any point is at the tangent. So this is the velocity which is the tangent to the circle. So tangent to the circle. C is the correct option. This is incorrect. Thank you for watching. Like the video, comment it and subscribe my channel so that you can be updated on the next post. See you in the next video.